Okay, boys and girls, so we continue our lesson number 6. Okay, because last week a lot of you are absent, okay, although we got the video recording. But then here today we before we goes to the past year questions, study about the past year questions, answer the questions. So we recall a bit about this worksheet number 6. Okay. So velocity time graph. Okay, here velocity is a vector quantity. So it need to consider direction. Okay, it need to consider directions. So from the velocity time graph, you will find out that sometimes the graph will be on the positive area, sometimes will be on the negative area. Okay, in my worksheet, I got two color. Actually, these two color, their motion are the same, but just one of them is in the opposite direction. Okay, so we know that velocity, if we going to the right, most of the time we will say that, hey, this one velocity is, for example, positive 4 meter per second. Okay, if let's say object moving in opposite direction, although the speed is the same, speed doesn't consider direction, speed is the same. Speed is also 4 meter per second, but here we need to put a negative for velocity to represent that this is opposite direction. Okay, to represent this is opposite direction. So when we plot the graph, if let's say at here, we found out that the green color here, negative 10 meter per second, what does it mean? Meaning that the object moving with the speed of 10 meter per second, but the negative showing that it moving backwards or moving in the opposite directions compared to the starting motion. Okay, so for these two, actually their motion are the same, just direction is opposite direction. Okay, so here velocity time graph, what information we can get from this graph? Actually two. One is about the gradient. Okay, gradient is y2 minus y1 divided by x2 minus x1. Am I right? So at here, meaning that your v minus your v divided by t, y divided by x. So v divided by t, velocity divided by time, what we can get? We can get acceleration. Okay, so gradient for velocity time graph, we can get acceleration. Okay, another important information is area under the graph. Okay, we're finding the area under the graph. Okay, so we are using, if let's say like this, okay, the graph like this, so we are finding triangle. Okay, area under the graph. So you should using 1/2 times the base times the height. Okay, that is your area. Okay, what information we can get from the area under the graph? Your V, okay, V times your T. Okay, your speed times time. Your speed times time. So this is distance. If we're using the unit to check, okay, unit for the speed is meter per second. Time in second, per second and second can be cancelled. Then you will left over the unit of m. Unit of m actually is the unit for distance. So when we do calculation for area, we are calculating the distance. Okay? So this is the idea. Then after that, this one we already discussed last week. Okay, here. The things that I want to emphasize is here, okay? Area under the velocity time graph. Okay, as I told you, they got two areas. One is at the positive region, another one is negative. Positive meanings that it moving in one direction, forward direction or specific direction. Okay, so when it moving in a specific direction, no matter how of the motion, is still moving forward. For example, at here, section 1. Okay, section 1 at here, let's say at here. Okay, this one is it increasing the velocity. So it is accelerate. So maybe certain part at here, it is accelerate. Accelerate, okay? Because got gradient, constant gradient. So it's constant acceleration. Remember, just now I say gradient of velocity time graph actually is acceleration. So constant gradient meaning that constant acceleration. Okay, how about the second part at here? This one, horizontal, meaning that this is constant velocity. Okay, constant velocity, it might be moving with a certain moment, okay, with a certain distance, but it's still moving forward. Okay. the last part at here for this part, okay, this is the gradient is negative gradient. What does it mean? Negative acceleration meanings decelerate. So this part is decelerate. But no matter you are constant acceleration, constant velocity, constant deceleration, you're still moving forward because your velocity is in the positive region. Okay? But then when it comes to here, the bottom part at here, this part, the velocity right now is at negative region. Okay, so here is 0. Let me label, this is 0. So the bottom part is negative velocity. What does it mean, negative velocity? Just now here we did mention negative meanings opposite direction. So right now, okay, right now at here, meanings that from B point at here, it start to moving backwards. Okay, so at here it start to comes to this point, it start to moving backwards. Okay, then for this part, what is the motion? Okay, here is velocity 0. Here maybe like negative 5. I just simply put some value negative 5. Is it slow down? My answer is no. It is increasing velocity. It's acceleration. Why, teacher? Because this is 0. Then it increase to 5 meter per second. So the negative doesn't mean that it slow down. Negative showing opposite direction. So you want to know, is it increasing the speed? You just look at the magnitude 0 and 5. 0 become 5 is increasing the speed. So for this part, it's increasing velocity, or we say acceleration. Okay, so this part, what color I should use? Let me choose others color. Okay, using this. Okay, this. So this part like this, okay, is moving backwards. Okay, then after that, what's going on? Green color. Okay, green color here. So for this part, what is the motion? This motion is, it is decelerate, because from the 5 meter per second, then go to 0 meter per second. So the last part, last section at here, this is decelerate, and then stop at here. Okay, so let me change back the color. Okay, so boys and girls, why I need to emphasize for this? Because for these questions, we like to asking you, what is your total distance, or what is your displacement? This total distance is very easy. You just count total path only. What? For example, this area, total area that I get is 10 meter. So you start from here, move 10 meter. I don't care how you move, because distance is scalar quantity. So we don't need to care about directions. I just need to know your total path. So from here, let's say I go back, this area is 3 meter. So what is my total distance? I just using 10 meter plus 3 meter settle. My total distance is 30 meter. So how we are going to find the distance? We are using the area A plus area B, the total distance traveled by the object. But here, boys and girls, how we are going to find the displacement? Okay, displacement is what? Starting, ending, that shortcut path. We need to consider direction, because displacement is vector quantity. Okay, so at here, this is my starting point. Here is my ending point, right? So the distance between starting and ending, this is my displacement. How can I find this? Okay, I can using 10 meter minus the 3 meter. So I know that this displacement is 7 meter. So at here, how you are going to find displacement? Distance in area 1, area A, minus the distance in the area B. That is our displacement. Okay, boys and girls, until here, is that clear? If okay, then we are going to proceed to the exercise. Okay, good job. use the reaction button. So you press it, then I understand that everybody get it, so we can proceed, okay? At the bottom part, yes, thank you. Like dear, we go to your next page number 4. Okay, this one is the past year question 2017. Velocity time graph for the train starting from one station. So at here, starting from one station, then stopping at the next station. Okay, another train has double acceleration. Acceleration become double. So ask yourself, velocity time graph, how we get acceleration? Think, just now only two, right? Either is gradient or actually is the area under the graph. So for this one is talking about gradient. Okay. So double the acceleration. What does it mean? Double the gradient. Get it? So your new graph for another train, it should have a greater double gradient. Okay, steeper line. Okay, gradient double, that means steeper line. The line will become steeper, but with the same maximum speed. Okay, and the same deceleration. Deceleration is also acceleration, but in negative a lah. So that means that your gradient, okay, gradient for this part is the same. Okay, this gradient is the same. So which velocity time graph on the same scale shows the motion of this train between these two stations? Okay, these two stations are there. Two stations. Will you change the distance between these two stations? You move faster, your friend moves slower, but distance between these two station, are they changing? My answer is no. So at here, same stations. So at here, same distance. Okay, so you need to fulfill these few requirement. Okay, from station 1 to station 2, distance is the same. But right now, I have a second train, which has the double acceleration. Then achieve same maximum speed. Then at the end, same deceleration. Okay, boys and girls, can you try using your understanding A, B, C, D? Which one is your correct answer? And then if you get the correct answer, you type your answer in the chat box to Newton Scholar. Dr. Lo is my iPad. Okay, I will using the Newton Scholar here, the chatting box at here to check your answer. Okay, you try. Chloe, yes. Chloe, good. Jiaxuan, no. Jiaxuan, try again. Jiaxuan, yes. Correct. Junxiong, try. Ryan, Hui Tong. Junxiong, yes. Correct. Sajan, try. Okay. Junxiong, I'm in Marvel. Haha, 6 a.m. in school until now. Wow. Okay. 6 a.m. Actually, I'm also the same. 6 a.m. I depart from my house, goes to school. Then after that, until now, yes. Okay, here deal. The rest of you, Clement, Ryan, Hui Tong, Clement. Clement, no. Later you check again. Okay, dear, we want to fulfill same distance. So, and then here, the starting at here is, you see, the gradient should be double steeper, okay? Double gradient. So that means that you must be something at the front, okay? This one, double gradient. So the answer for A, B, C, D all fulfill, yes, all fulfill, yes. Then they maintain with the constant speed. Okay, how long we don't know. We want to achieve that same distance. Okay, for this one, how long we don't know. Then they say that same deceleration, two box. So at here, 1 2 1 2 1 2 1 2, always 1 2. Then the only thing that we can solve is we find the distance. Okay, for this one, distance is actually area under the graph, am I right? So at here, we can using the trapezium, your mathematic trapezium, okay? So I'm counting 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9 plus 1, 2, 3, 4, 5. 9 plus 5 times the height. 1, 2, 3, 4, 5, 6, 7, 8 times 8. So for the first one, answer is 56 meter. Okay, here we want to find that at start what is their distance, total distance. So this one area under the graph represent the distance. So the distance at here is 1 over 2 trapezium mathematics. So 1, 2, 3, 4, 5, 5 plus 5, 6, 7, 8, 9, 10, 11. So this one plus 11 times the height is should be the 8. Your answer is 64 meter. Okay, this one is train A. It travels 64 meter between the two stations. So A is the wrong answer. How come you change another train but shorter distance? The distance won't be changed what? The distance between your school and your house is the same. Just maybe today you're using motorcycle. Tomorrow you're using the bus, the van or whatever. Okay? So at here, answer should be B. Using the same method, continue. Okay, do calculation. So this one, the distance, you should get 64 meter. The distance, you should able to get 72 meter. So this one, distance, just repeat the same thing and do calculation, 48 meter. Okay, is that clear for the idea? Clement, did you get the idea about this? Is it okay? Okay, how about others? If okay, then we are going to proceed to question number 2. Give me the reaction so I know that you're able to follow. Okay, Who else? Who else? Okay, Chloe, okay. Okay, dear. We goes to the next question. This is 2013. The graph showing the velocity time graph. At which point the graph does the rocket have the greatest acceleration? Again, ask yourself how you relate acceleration with your graph. Okay, tell me your answer. Um, Sergeant, I sent in the you are not in our group. Wait because just now the sending the worksheet is actually Mr. Cheng, not me. My bad. Because I thought we finished this lesson, that's why I sending the 7 and 8. Can you ask your mother, ask the Mr. Cheng to send to you? It's my bad. Okay, let me check Chloe. Chloe answer correct. Jiaxuan correct. Clement correct. Junxiong correct. You ask your mother, ask Mr. Cheng. Just now, roughly like 6 or before 7, I realized that we will continue for this worksheet. So I did sending to Mr. Cheng because I don't have your contact. And then worksheet I sending in the group, but today you are trial class, that's why you don't have the worksheet and you not in our group. Okay, boys and girls, this answer is correct. Your answer is correct. Answer is B. Okay, greatest acceleration, that means that greatest gradient. Okay, how we know the gradient? You see, draw like this. Okay, draw like this. Triangle, the triangle, like this, triangle. Then this one, at C point, at C point, what is your, one of the past year question asking, okay, which point actually acceleration is 0? So this one, acceleration is 0 because the gradient, no gradient, okay, at this point is acceleration 0. Then here answer is B, okay, greatest gradient, greatest gradient. So, like how can I say? If I want to find the triangle, we can drawing the triangle like this. Okay, like this. Am I right? So I can just using one line shortcut, one line to represent this is my gradient. I want to see that the line is steeper or less steep. Okay, I don't need to draw a full triangle. I just draw the line. Then I know that the gradient actually is higher gradient or lower gradient. Okay, boys and girls, we goes to your page number 5, question number 3. Okay, next. Sergeant, so you look at my screen and try together. A radio control toy car travel along a straight line for a time of 15 seconds. So this is the velocity time graph. What is the average velocity of the toy car? Okay, can you try? At the same time, I take attendance, dear. Take attendance. Wow, so fast you guys already get it. Wait, yeah. Okay, later I continue. Okay, let me have a look. Junxiong, yes, correct. Chloe, yes. Jiaxuan, no. Jiaxuan, check. Okay, dear. Average velocity is we using displacement divided by time. Am I right? So that means that from this graph, you have to count the displacement. You have to count the displacement. So this part area is no 1 over 2 because this is a rectangle. Don't everything count 1 over 2. No, this is wrong answer. Okay, so you should this one is 3 times 10. Okay, how about this one is 5 times 6, so which is 30. So this one is 30. Okay, as I told you, displacement is using area A minus area B. So displacement is the distance traveled by area A minus travel B. So divided by the time. So 30 minus 30 divided by the time, which is 15. At the end, your answer still 0. Answer should be B. Okay, answer should be B. What does it mean? After 15 seconds, where is the object? Object go back to original position. When displacement is 0, meaning that object go back to original position. Is that clear? Dear, is that clear for this question? Okay, Okay, thank you, dear. So here, they're asking you, a object moving in a straight line. The graph shows the variations with time t of the velocity v of the object. At time t equals to 0, okay, and starting at here, object is at point x. So this is at point x. Question asking you, what is the displacement of the object from point x at the time of t equals to 0.8? After 0.8 second, what is the displacement? Okay, can you try? Junseong, yes, correct. Junseong, I help you rename your name. Participant, I cancel. Okay, I change your name. Okay. Chloe, no. Chloe, no. Chloe, correct. How about others? Displacement. Okay, here, this part. This is moving in one direction. Positive, this is moving in opposite direction. Okay, opposite or either one. Okay, so at here, this part, this distance it travel and then end the 0.8. Read the question carefully. Do not count for everything. For this part is another direction. Okay, so starting from here, this point is actually in one of the direction is moving. Okay, maybe I can set that this one as my to the right, okay, or to the left lah, doesn't matter, to the left. So it moving like this, going to the left until the time is 0.2 second. Then after that, it's starting from 0.2 second, it moving backwards, okay, it moving backwards. So the pink color one, okay, I highlight this is pink color area. Okay, then this one is the blue color area. Okay, what is the displacement? So this one is after the time is 0.x second. What is the displacement? So your displacement should be starting to ending. This is the distance. Okay, so what should you do? This is displacement. What should you do is you count for the blue color triangle, the area, the distance. Then you count for the pink color. Then you minus it. Okay, so at here, displacement, it should be, okay, because the pink color region is actually larger distance. So I'm using larger distance minus the smaller distance. Okay, so this one is 1 over 2. Then the height is 6. The base is actually 0.8 minus 0.2. 0.8 minus 0.2. Okay, this one is pink color at region. Then minus 1 over 2, the blue color region is should be 2 times 0.2. Okay, so if you do everything correct, your answer should be 1.6 meter. Get it? So 6 times 0.6 divided by 2. The pink color here is 1.8 meter. Then this one 0.2 times 2 divided by 2. So it should be 0.2. Here is 0.2. That means that this part, this part, it travels 0.2 meter. Then the opposite direction, it travels 1.8 meter. So what is the displacement? You're using 1.8 minus 0.2. That is your displacement, which is 1.6 meter. Answer is A. Okay. Do you guys get the idea? Is it okay for you? Is it okay? Clement, okay? Hui Tong, do you able to follow? And Ryan? Okay. So we go to the question number 5. Goes to question number 5. Okay, here I don't guide you. Do you able to try? A ball is released from rest. Okay, released from rest above a horizontal surface. It strike the surface and bounce several times. So it should be like this, going down. So at start here, u equals to 0. Starting velocity is u equals to 0. Okay, then after that, hit on the floor and then bounce up. Okay, what is the maximum height for the first bounce? So you have to think which region actually represent about this. Chloe, yes. Oh, Chloe, very good. Yes, correct. How about others? So this one is at rest, starting at rest. So it go and hit on the ground. So this part is hit on the surface, okay? Hit the ground or hit the surface. Okay, then, Xiaoxuan correct. Junxiong correct. Okay, so this point, it hit on the ground. So it suddenly, hit on the ground. Then after that, it going up. Okay, right? It going up until a maximum height. So this one is the first bounce, okay? First bounce, maximum height of the first bounce. So at here, this is at the time 0.3 second, it hit on the ground. Then after that, what's going on? It will go up. Sajan, yes. So this one is go up. Here will go up. Okay, so Go up until where? Until you get a maximum height. When you get maximum height, what is your velocity? Velocity is 0. When you against gravity, you will decelerate. Your velocity will decrease until maximum height is because there is no velocity anymore. So where is the point that velocity is 0? Here. This point. Velocity is 0 when maximum height. So I want to know the maximum height. How can I know, dear? From the ground to the here, this is my maximum height. So that means that this region actually is our distance that it bounce upwards. Okay, first bounce. So it going up. So you just count for this area under the graph for these sections. So 1/2, 2 times 0.2, your answer should be 0.2 meter. Answer is A. Is that clear? Is that clear? Not clear? Which part not clear? If clear, then give me reaction so I know that we can proceed and I explain clearly, okay? Good job. Dear, do you still remember my worksheet here? This one. When we drop the object, okay, drop the object, velocity increase because gravity pulling, object accelerate. Then hit the ground. Then from here, the ground is going up. So this is the maximum height. The maximum height is when the velocity becomes 0. Okay, is maximum height. So at here, the front part, this part is object falling. Second region at the bottom part, this one is object rising. Can you see that? Fall and rise is opposite direction. That's why it formed two regions, positive area and negative area. So just now the question, how we interpret, this is the method. Okay, this one is going down. Here is going up, opposite direction. Okay, we go to the question number 6. Can you try? Chloe, yes. Session now think again about how the velocity will change. What is the motion of the ball? At start, roll in a straight line up a ramp, up a ramp. So what is the motion? Junxiong, yes. Sajan, no. Sajan, I want to ask you, and also Chloe, is it just now, Chloe? Jiaxuan, I also explained to Jiaxuan. Jiaxuan almost there, but not the correct answer. Okay, let me explain to you why C is not the answer. Just now got two students choose C. You see a ball roll in a straight line up, up, up. So this one is up. So I can think that my ramp is something like this. Okay, your ball is trying to go up. When you go up like this, can you tell me that your velocity will increase or decrease when you're going up? Your velocity will be decreased. Am I right? When you're going down from here, okay, so it said that back down, going back at here. So this one is you will speed up, velocity will increase. So you see, for the first region, velocity decrease. This one confirm wrong. B confirm wrong. Because the velocity is not increased one. It should be decreased. So C also wrong. Okay? C is actually just now the case. The ball falling, velocity increase. After that, it going back, bounce up. Okay, it bounce up. So the velocity increases. Okay, so B and C confirm wrong. Only A and D. Okay, you see, A is decreasing. D at here, the front part also decreasing. So the front part is correct. But why Jiashen answer choose D is wrong is because, can you see that it going up and then going down? Going up and then going down. They are opposite direction. Opposite direction, that means that you must involve with positive region and negative region. So D, this part is wrong. This part is velocity increase, correct? But it should be not in opposite direction. It should be in opposite direction. So this one is 0, maybe here is 10. But negative showing direction only. Actually, it's speeding up. Okay, so this one velocity decrease, here velocity increase, and then some more in the negative region, this is opposite direction. Your answer should be A. Okay, is that clear? Did I explain clearly? This one up, so you circle this is down, so you write down opposite direction. Okay, opposite direction. So it must be involved with velocity, positive and negative. It must have these two regions because up and down opposite direction. Okay, if no question, we are going to the page number 7, question 7. Okay, let's go here. Okay, read the question and try. If you make mistake, also no need to shy, because nobody know you, right, dear? I also don't know you. Even some more you didn't open your camera. So it's okay to try. Okay, even though your answer might be wrong, it's okay. Just try, okay? Question number 7. Jun Xiong Rong, try. Chloe, no, try. Chloe, yes. Jiaxuan, no, almost there. Jun Xiong, frictionless, that means that no energy loss. No energy loss. Clement, correct. Clement, correct. A ball is set in motion at P on a frictionless surface. That means no energy loss. Okay? Jia Xuan, correct. Jia Xuan, correct. Sajan, yes, correct, dear. Correct. Okay, here, frictionless, that means that no energy loss. It move up. If they move up, velocity should be decreased. Okay, going upward. Okay, then horizontal and finally descend. Okay, here it will be velocity increase. Here velocity decrease. Here it should be a constant because horizontal constant velocity. Okay, so at here decreasing velocity, yes, decreasing velocity. Then this one no. D confirm wrong. First section already can cancel. Answer D. Okay, then after that horizontal, so it can travel constant velocity. So this part and this part is correct. So B, no. Okay, then after that, last part, velocity increase. Teacher, these two seems like correct what? They're almost the same. But is it they are the same? My answer is no. Answer should be A is because you see, let me draw it out. This one velocity. Because of the energy is conserved. Okay, I write it here. Energy is conserved. Okay, your final velocity impossible. Impossible cannot greater than your initial. Okay, greater than your initial. Cannot. So this one is, that means that you got any extra energy to provide a higher velocity. So this part is wrong. Answer A is correct. Is that clear? So frictionless, that means that energy is no energy loss. Energy is conserved. Okay, dear O, is that clear? Chloe, okay. How about others? Jun Xiong, okay. Who else? Okay, so proceed. I continue, take my attendance. You read it and then you tell me the answer. Attendance, Clement, Chloe, Ryan, Jia Xuan, Wei Tong. Okay. Okay, let me check the answer. Chloe, no. Try. Yes, Chloe, correct. John, no, almost there. Clement, almost there. Xiaxuan, no. Okay, dear. Answer should be donkey. Those who choose B, your answer is almost there, but not correct. Dear, this one is almost similar with just now this question. You see, it will provide a sudden change. Okay, when they hit on the whatever surface, they will have provide a sudden change. So for this one, is actually a constant acceleration, okay, or constant deceleration. Okay, so at here, why the graph must be correct? So the point is constant acceleration or constant deceleration. So you imagine object falling down or object throwing up. We will say that the A is 9.8 meter per second per second. This is negative 9.8 meter per second per second. It is a constant acceleration or constant deceleration. So what we expect is it must be a straight line. Okay, straight line. It's not a curve. So all these curve actually we can cancel out. What is this? Okay, then after that it will provide a sudden change. Okay, it will provide a sudden rapid change. Okay, because it hit and then it changed direction. Okay, it changed direction. So at here our expectation is sudden change. So this part is wrong. Okay, so when you saw the one what some jumping, bouncing, collisions, okay, so they will have sudden change in direction. So answer donkey is the correct answer. Okay, is it okay? Teacher, going down will always be positive, while going up will always be negative. Doesn't matter it's release of the ball or trampoline. Actually, directions we can decide, but most of the time to be easier, we will say that going down is positive, then going up is negative. But if you say, teacher, I want to be going up as positive. Yes, it's fine. It's fine. Okay, going to the right is positive, going to the left is negative. Teacher, can I change? Yes, it's fine. You goes to the left, you can put positive V. Then you going to the right, you have to put negative. The positive negative is just showing, try to tell us that the negative actually is oppose the initial motion. Opposite direction, not oppose, sorry. Not oppose the initial motion. Is opposite direction to the starting motion. That's all. Okay, it can be we decide by ourselves. Okay, is it okay? Junxiong okay? How about others? Get either Clement okay? Chloe okay? Okay, then test on your understanding for the next question 2018 velocity time graph. Okay, they want you from the velocity time graph change to this displacement time graph. So I need you to think what is the possible answer. Chloe, no. Jiaxuan, no. Same answer as Chloe. Think again. Chloe, no. Jiaxuan, yes. Junxiong, no. Sajan, no. Clement, yes. Dear, displacement. Okay, here, how you relate displacement, time graph, and velocity. Okay, from here, displacement time graph, gradient is gradient of ST graph actually is represent your velocity, right? So that means that when we solve this question, I have to refer to the gradient, okay, to interpret the velocity. So first region at here, this part, we study about the velocity, what happened to the velocity. Velocity from certain value to goes to here, velocity becomes 0. So that means that here velocity decrease. Am I right? Velocity decrease. It's moving forwards, but then the velocity is decreased. Then after that, from certain time at here, okay, let's say I say this is T1. After a certain T1, it moving backwards, so it will moving in opposite direction because here this region is negative velocity. Negative velocity, so here is positive velocity. That means moving backwards already. So this one, moving backwards, how was your velocity? The velocity is increased. Get it? So there is two part, two section. From the graph, two section. Okay, you ask yourself, velocity decrease. So in the displacement time graph, now I drawing displacement time graph. Last week lesson, ST graph. Okay, if the object moving like this is called stationary, object not moving, right? Okay, if the object like this, okay, the motion graph like this. So what does it mean? This is constant gradient. Constant gradient means what? Constant velocity. Am I right? This is constant velocity. So your answer just now, a lot of you choose answer D. Confirm wrong. Why confirm wrong? This is meanings that constant velocity. This is constant velocity. Why constant velocity? Because constant gradient. This one, if I talk about the gradient, this is constant gradient. This is constant gradient, constant velocity. But here, the graph that we interpret, the velocity is changed, decrease. So answer donkey confirm wrong. So this part, answer donkey, the first part is already wrong. Okay, then, so at here, we study if we curve a curve. Okay, for the ST graph, we curve like this. Okay, so as I told you, we can draw the line like this to show the gradient and draw the line like this to show the gradient. Okay, like this. So you will find out that your gradient decrease. Am I right? For this one, gradient decrease. Gradient decrease means what? Velocity decrease. So can you see that this is the part like this and then like this? Oh, I draw like this. Okay. Can you see that the gradient decrease? Gradient decrease. Less steep, the line less steep. So this one means that this region velocity decrease. Velocity decrease. Okay, this part constant gradient also wrong. Same idea, same idea with this. So it's wrong. Only A and C we need to consider. Okay. Then why our answer, final answer is A is because can you see that at here? The next second section at here. Velocity is negative. Velocity negative and some more velocity negative meaning what? Just now I told you they move backwards. If move backwards, what does it mean? You move towards to your origin. So that means that they change direction. You should going back. you should move backwards. Your displacement should be decreased because you're moving backwards. Okay, just now let's say here is 10 meter. Now you go back with 3 meter. Your displacement becomes 7 meter. So you are nearer to your origin. So that means that from here we should go back. Okay, when we going back, we change direction. So at here, this point, so we start to move backwards. Okay, this part, you also do the same thing. You draw the line to show the gradient. So can you see that? The second line, the last section line, the line is steeper. Steeper. What does it mean? This gradient is higher gradient. Higher gradient means that your velocity increase. Because gradient represent your velocity. Answer, it should be A. So you have to think very clear. Does it change direction? How about the motion? And how's your graph? Okay, question number 9. Is that clear? Answer is A. B and D confirm wrong. Okay. But those who choose D, I must say you are good because you understand that you understand it's moving backward. At least this idea is here. Just the graph is wrong graph only. Okay? Good, Okay. Sergeant, is it okay for you? Hui Tong? Ryan, okay? Okay. So there we goes to your number 10. Question number 10 here. Okay, a mass on the end of the spring will bounce up and down. Okay, it will bounce up and down. Okay, this one is at the bottom part position. Okay, which graph show how the velocity varies with time? Okay, try. Chloe, no. Okay, like this. At time t equals to 0. So this one t1, t2, t3. Then T2 is at the maximum position, highest position here. So ask yourself, try. So this one you have to think very carefully about the motion of the object that hang on the spring, how it moves. There I give you some hints, okay? You look at this, this is lower position. After that, it will go up. Am I right? How is motion? At this position, the velocity, is it maximum velocity or actually minimum velocity? This is the hints. Junxiong, yes, Junxiong correct. Ask yourself at lowest position, the velocity at here actually is maximum or minimum? Maximum or minimum? Then after that goes to here, the velocity should be maximum or minimum. Then after that goes to here, the highest position, your your what? Your velocity is maximum or minimum. Okay, so at here, this is maximum height. At here, maximum height, your velocity is 0. Then at the lowest point, lowest position, lowest point, your velocity also 0. So where is the point that the object having the highest energy, a higher speed, actually is here at this position is maximum V. So this one, mark it down. Okay, that means that at start, at lowest position here, our speed at here is V equals to 0. So this point is correct. Then this point is wrong. This point is correct. And here also correct. Okay, B is wrong already. We can cancel out B. Because at lowest position, velocity is 0. Then it start to going up. Okay, the EPE, elastic potential energy, it convert to kinetic energy. Okay, so it start to going up. When it going up at here at the middle, that is the maximum speed. Okay, in maximum speed at T1. So this is T equals to T1. Is the maximum speed. So at here maximum speed. B no need to think. Here the T1, if I draw the line going down. Okay, so this one is wrong. Here okay. Okay. Then after that at T2, T2 is going up until the highest position. At that position, velocity is 0. Therefore, it will going down again. It will change direction. Every time object change direction, it must be goes to velocity goes to 0. It only can change direction. Okay. So every time when we want to change direction, please your velocity is actually 0 already. So T2 at here, I going down like this. T2. At T2, actually this point, the velocity goes to 0 again. So this one correct. Here is wrong. No need to have a look. So this one also wrong. So here also wrong. Answer should be A. So this question is test on you. Do you able to identify the motion at every single position? Digest. 10 seconds for you to digest. If any question you want to ask, you ask me. Lowest position and maximum position, highest position, the velocity must be 0 because they want to change direction, what? Right? They change direction. So at the middle, that is the maximum speed. Then it decrease the speed again. Is that clear? Is that clear? T3 also maximum speed, right? Yes. Yes, T3 is again maximum speed. Then T3, you see, T3 is it going back at here. So this one is T3. It going back at here, T equals to T3. But just now is we going up in this direction. Now it's going down in this direction, opposite direction. Therefore, it in the negative region. Here is positive region. Zhixiong, okay? Opposite direction. Maximum speed, then opposite direction. Okay, dear others, any question? If no question, give me response. Then we can proceed to the next question, 11. Okay, Clement, okay. Chloe, okay. Sajan, okay. Okay, dear, we comes to the question 11 at here. Actually, it's the same idea. I purposely make these two questions together because it's talking about the same spring. Okay, so the spring moving up, down. So question asking you which point represent the velocity of the mass when at the lowest point of its motion. Okay, think. Lowest position at which point? Chloe, yes. Chloe, correct. How about others? Any others? What is the answer? A, B, C, D. Which point, which velocity point is represent your lowest position of the object motion? Okay, A, B, C, D. At lowest point. At lowest point at here, velocity must be 0 because it's going to change direction. But which one? Clement, no. Sajan, yes. Dear, my answer it should be Junxiong, yes. My answer should be donkey. Okay, why, dear? Why? You see, here there is one thing important. This one, they set the positive as up. Okay, positive region as up. So that means that I must be depart from here going up. So this is my point A. Goes to point A. Then after that, I continue going up. This is my point B. Okay, this is my point B. Then after that, here is negative. This is going down. So it changed direction already going down. So this is point C, goes to point C. Okay, then point C, then going, decreasing the velocity. So this one going down again. This is point D. So your lowest position should be point D. Here, answer D. This is a very interesting question. Is that clear? They might be changed. Say that velocity positive is down. Then your answer will be changed. Okay? Then you have to think from here going down X point, B point, C point, and C point. So actually at here, your point should be B. Something like that. So this one important. They tell you that positive is meaning going up. So our motion is starting from this lowest position going up. This point is lowest point. Then it going up, up. Then change direction going down, down. Lowest position is D. Is that clear? Okay, then can we proceed to the page number 10? Next question, page number 10. Okay, you read it and then you try it. Velocity time graph. Chloe, yes. Xiaoshen, yes. Is it easy? Okay, try. Junxiong, no. Junxiong, try. Again, try again. Any others? Clement, Hui Tong, Ryan, try. Okay, so we divide into 4 sections. Actually, can divide it into 4 sections, okay? But here, the first one is moving in one direction, okay? Object moving in one direction. So this one, negative velocity, meaning that moving backwards. In moving backwards, okay. Then for the first section at here, I draw the line to show the gradient. So the first section at here, my line become less steep. Steeper? It becomes steeper, less steep. Well, oh, sorry. This is velocity time graph. Okay, velocity time graph. So this one, I know that velocity increase from 0 to something. Then this one, velocity decrease. Okay, I cannot look at the gradient. Gradient is I looking at the acceleration already, but now the graph is displacement time graph. Okay, so I don't need to look at the gradient. Then this one is 0 to some value, so this one velocity should be increased. The last section velocity should be decreased. Okay, we already finished interpret the graph. How we convert it into displacement time graph. Okay, so we also divided into 4 sections, half of it first, okay? Convert half of it. So I want to check the directions. Okay, so at here, the first part, first section at here, this part, velocity increase. So gradient for ST graph is actually velocity. Okay, so my velocity increase, my gradient should be increased. So this one I draw like this. Then here we draw like this. Okay, so can you wait? This is 2 sections here. Okay, here like this. Okay, we divided into 4 sections. 4 sections. So I'm using my green color like this. Section 1, 2, 3, 4, something like this. Okay, can you see that this one, the first sections, my gradient is increased. So this one velocity increase. Then after that, here like this, and then my graph like this. So gradient decrease, velocity decrease. So first section is correct. First section is correct. Okay, B at here is incorrect. Why? Okay, this part also incorrect. The first part also incorrect. You see this one and here. This is meaning that velocity decrease. So first section is wrong. Some more is starting from here already start to move backward. But no, we are starting from the half of the journey, only change direction. So this one, first section, after first section, it already changed direction. So B is wrong. C also the same. Okay, C also the same. You see, if you draw the gradient for here, the velocity should be decreased, but this is wrong. And then some more here already start to move backwards, so wrong. Then this one also the same. You see, start from here already move backward, wrong. The only answer is A. The only answer is A. Okay, then I draw it here like this and like this. The gradient increase, so velocity is increased. Then after that, at here like this and like this. So velocity decrease because the gradient decrease. Okay, any question? Actually, B, C, D, from this, we already can cancel the answer because they haven't changed direction. But answer for B, C, D, they start to change direction after the first section. Actually, we are divided into 4 sections. Okay, after the first 2 sections, they only change direction. The only answer can fulfill is only A. Okay, first time you learn about AS, so this kind of question you need time to digest. Okay, you need time to digest. So here, you always ask yourself the velocity and displacement graph. How we relate them? We relate them by using the gradient of displacement time graph. Okay, so for the velocity time graph, I don't need to find the gradient because if I find gradient, it's talking about the acceleration already. Okay, Junxiong says, sorry teacher, the rest may I watch video? Yes, yes, yes. Okay, Junxiong, yes. Okay, dear, until here, answer A, is it okay for you? Okay, so if okay, then we goes to the page 11. We goes to page 11. Question number 13. Graph showing acceleration of an object moving in a straight line. The object start from rest. Okay, so velocity starting is 0. Which graph showing the variations with time of velocity? So you think the acceleration and velocity time graph, how you relate them together? Okay, so try. Chloe, no. Chloe, try. I give you some hints. I give some hints. We can divide it into section like this. So this one acceleration increase. This is acceleration decrease because A value what? Right? No matter acceleration increase or acceleration decrease, it still accelerate. Okay, that is my thing. Xiaxuan, no? Chai? Does it change direction? Does it change direction? Acceleration positive and acceleration still positive, but it's just decreasing the rate only. It's still positive what? This one. So this one in the positive region is still accelerate. It doesn't mean that it changed direction. So it doesn't change directions, B and C confirm wrong. Because here, oh no, this one is, okay, C confirm wrong. Because C at here showing that change direction, so C is wrong. But from our acceleration time graph, it didn't show that it's changed direction. Chloe, correct. Clement, no. Clement, do you know why? We didn't change direction. We still moving forward and then it still accelerate. Just increasing the rate or decreasing the rate. That's all. So C confirm wrong. Okay, then how? Acceleration increase. So we divided into two sections like this. Divided into two sections. Divided into two sections. Okay, acceleration increase. That means that acceleration increase, that means your gradient should be increased. Because we know that velocity time graph, it represents acceleration. Acceleration increase, gradient should be increased. So I draw the line and see whether your gradient increase. Yes. Okay. Then at here, like this. And then this one, wow, how many sections? Oh? It seems like this, you know. It seems like here is going like this, and then here is another section. For B, it seems like make it two section already. Okay, so velocity like this and then like this. So this part is actually decreasing decreasing acceleration, not decreasing lah. The gradient decrease, so your acceleration's decreasing. So this part is wrong. Okay, this part is wrong. Then this part saying that velocity is decreased. For this part, velocity is decreased. This is a wrong idea. From certain value goes to zero, velocity is zero. This is wrong. Because we know that it still accelerate. It should be still accelerate. So B also wrong for the second part. D also wrong. It seems like doesn't change. It's just one motion, which is here like this and like this. Gradient is increased. So for this, interpret your gradient increase, your acceleration increase. Only one motion. The correct answer should be A. Okay, digest, and ask me question. B, the very obvious mistake is the second last section, okay? Last section, velocity decrease. But you refer back to the acceleration time graph, acceleration still positive, but just decreasing the rate. So it still accelerate, not that fast rate only. So B, the second last sections, is very obvious mistake there. C, very obvious mistake is because velocity involved with negative region. That is meaning that change direction. But from the acceleration time graph, there is no changing of direction. Okay, D, there is only one motion. From starting to ending, only one motion, which is acceleration increase. Okay, but here, second last section is actually acceleration decrease. So our answer should be A. So if I draw like this one, and here, can you see that gradient decrease? So velocity decrease. So this one velocity increase because the gradient is increased. Answer should be A. Is that clear? Clement, okay. Clement get the idea. Then any others? Sajan, Jiaxuan, Chloe, okay, because Chloe choose the correct answer. Ryan, okay? Sajan, get it? If didn't get it, tell me. Okay, good job. Ryan, okay. Sajan, okay. Okay, deal. We go to the 2023 past year questions. Okay, the variations with time of the velocity v of a car that is moving in a straight line. Compare qualitatively, meaning that no need to do calculation. The acceleration of the car at time x at here, okay, this point, okay. What is the acceleration values compared to the time 14 here? Okay. What is the magnitude? Can you compare and then tell me? Acceleration, magnitude, and direction. Try, type your answer, then you let me know what is your answer. None of you can give me the answer? No way, please. Is it? No, Chloe, no. Ask yourself how to relate acceleration and the velocity time graph. Acceleration and velocity time graph, how you relate? The gradient for the VT graph actually represent your acceleration. Okay, so at here, this point, the gradient and compared to this gradient, that is the magnitude for your acceleration. So which one steeper? Which one the line steeper? Actually, at time 14 second, that is steeper line. The line is steeper. Okay? That means that the magnitude for acceleration at x second actually is less. So we write together. Magnitude of acceleration at t equals to 8.0 second is less than that at time equals to 14.0 second. Okay, it's less. Acceleration is less. Okay, the magnitude is less. Why? It's because less steep. The line is less steep. Gradient is less. Gradient is lower.
Teacher,
Yes.
can I ask, like, because at t equals to 14 second, it's already decelerating. If it's
Yes.
decelerating, then the acceleration is supposed to be negative. But
Okay. Dear,
but
I know. That is magnitude. Now we're talking about magnitude, dear. We're talking about magnitude. So if let's say A equals to, okay, if you do some calculation, 20 divided, okay, let's say I put at here to find the triangle. 20 divided by 12 minus 4 is 8. So my starting here, my acceleration is 2.5 meter per second square. Okay, now I draw another triangle to find the gradient for the second sections. So my second acceleration should be a negative. Yes, 20 divided by 4. So I will get 5.0 ms negative 2. Am I right? So at here, magnitude is, look at this only, magnitude. So the magnitude for the x seconds is actually less than the 14 second. That is magnitude, 2.5 less than 5.0. And then the negative at here actually is related with this direction. Okay, so here, if you want to talk about this, then look at this. I got two car. Okay, like this. This is the car. Okay, the car is moving towards to the right, towards to the right. Okay, if there is another car, okay, like this, it's still moving in this direction, but the problem is the car is decelerate. Okay, just now this one is maybe 1000 forward thrust, then this one is 200 forward thrust. So your resultant force it should be the MA. This one should be 800 equals to MA. So of course your A will be a positive value. Okay, then here let's say this one still 1000 Newton, but here the frictional force is become bigger. Maybe there is a wind. Okay, so it become 1200 Newton. So your resultant right now, you see, resultant should be using the bigger force minus smaller force. So where is the direction of your resultant force? Backward, you know. So at here now your resultant force is in this direction. It's 1200 minus the 1000 equals the MA. So actually this one 200 Newton for your resultant force. Your resultant force right now is in the opposite direction with your motion. My red color arrow is actually direction of motion. But now, because the air resistance, friction, all is suddenly higher than the thrust force, so your resultant force right now oppose your direction of motions. Where is your acceleration? Your acceleration actually follow F equals to ma. Your acceleration follow the directions of the resultant force. So your direction of A is here, which is the 5 at here. 5, let's say I just simply put 5 meter per second per second. Okay, it's oppose your motion. This one should be put a negative because it decelerate. Decelerate. Okay, decelerate. So boys and girls, here when they question, they're asking you about magnitude. If I do calculation for this part, okay, my acceleration is 2.5. Then I calculate for the second part at here, I get negative 5.0 meter per second square. Magnitude is only compare this 2.5 and 5. Then if you compare the gradient, this one less steep, this one steeper. So our answer for this is magnitude of acceleration at time t equals to 8.0 is less. Okay, because 2.5 less than 5. Then negative negative actually is related with the direction. Okay, related with direction. If 1200 backwards friction greater than this, of course the car should be slowed down, right? The car should be slowed down. So our acceleration get a negative 5 meter per second per second. Okay, the negative at here is actually from the diagram. Can you see that it follow the resultant force direction? It follow. So you compare these two cases. You compare these two cases. The directions for the acceleration actually is in opposite. So we write the answer together at here for this. Direction of acceleration. Direction of acceleration at t equals to 8.0 second is opposite to that at t equals to 14.0 second. Okay, direction is opposite. Okay, this one is your resultant force. First case resultant force is here. So your acceleration follow. So it will be moved to the right. Then second case is frictional force greater. So the acceleration follow the resultant force, it will be backwards. So these two direction for these two are opposite. Can I write object move in positive direction away from origin? Move in. Okay, boys and girls, you digest. I study about Chloe question. Can I write object move in positive direction away from origin point at t equals to 8.0 second. Car move in negative direction towards origin. No, the car still moving forward, but it's just slow down. No, it doesn't move backwards. Chloe, it doesn't move backward. It's still moving forward. Just starting is accelerate, then decelerate. It's still moving back forward. Okay. So boys and girls, this one direction is opposite direction. Acceleration will follow the resultant force direction. Okay. So here, determine the magnitude of acceleration at time t equals to 4. Time t equals to 4. This one. Okay, what is your acceleration? So can you count for it? Okay, I put it here because Sarjan doesn't have the worksheet. Chloe, correct. Okay, at 4 here, what is your acceleration when time is equal to 4.0 second? The rest of you try. Clement correct. Jiaxuan correct. Okay, so at here, we want to calculate the at time 4.0 second. Can you see that? We can using this part, triangle, to find the acceleration. So this one, acceleration is equals to your gradient of Vt graph. So 20 minus here minus 10 divided by the time is 12 seconds. So you should get 2.5 meter per second per second. That's all, the answer. Acceleration, finding the gradient. Okay, finding the gradient. Okay, okay, here there is some space. I want to page number 11 got space. Okay, here. Okay, if displacement time graph, you finding the gradient, you are finding the velocity time graph. You are finding the velocity. From the velocity time graph, you finding the gradient, you are finding the acceleration. Then for velocity time graph, if you find the area under the graph, you will get back the distance or displacement. Distance or displacement, then next is velocity, then next is acceleration. This is their relationship. Okay, is that clear? Yes or no, dear? Okay, so here, next question asking you, the car is at point X at time equals to 0. So that means that at here, starting at here is at point X, at point X. Then determine the magnitude of displacement from X at time 12. So until here, it travel from here 12 seconds. What is the displacement? Can you count? What is the displacement? Okay, what is the displacement? Chloe, no? How you find displacement? Jiaxuan, yes. Jiaxuan get the answer. How about others? From here until 12 seconds, what is the displacement? Still remember at start I recall I purposely mentioning about how to find distance and displacement. Chloe, correct. How about others? Clement, no. Okay, dear. This is the distance traveled. Always remember area under the graph. Is the graph towards to your x-axis? Okay, then here 12. So that means that this one distance under the graph, this part. Okay, so you calculate lah. You calculate this area. This one is A, here is B. Okay, total distance traveled in the B region minus the total distance traveled in A region. Why need to minus? Because they are in opposite direction. Velocity positive and velocity negative means opposite direction. So we should minus it. Okay, so if let's say here, okay, let's say this one is x point, which is okay, starting from x point somewhere here, in moving to the left. Okay, in moving to the left. Then after that, moving to the left. Then after that, goes to time t equals to 4, t equals to 4. It changed direction. It changed direction. It start to from here moving backwards. Okay, so we set that to the right as positive lah. So until here, time is equals to 12 seconds. So how you find the displacement? You should finding here. Using the distance at region B minus the distance at region A. If you do it all correctly, your answer should be get 60 meter. Did you able to get 60 meter?
Teacher,
Yes,
I
dear.
want to ask because they say point X or because point X is like at minus negative 10. So shouldn't it be plus together?
Plus
Like,
together. Velocity and position is different. So you can take any point as your point X starting point. You can take any point as your starting point X. But that is just telling you initial speed is 10. Then decreasing the speed. It doesn't mean the position. Your X point can be anywhere.
oh, okay.
You try to think again, then ask me again. Okay. So X can be any point. So at starting at here, X point, the speed is 10 meter per second. Then it will start to decrease to 0 before it change direction. So I draw to the left is I assume that velocity and negative meanings that move to the left. So here U equals to 10 meter per second. Then this one, before we change direction, the velocity becomes 0. Then velocity becomes 0. Then we change direction from time equals to 4 seconds. So we increase until our speed is becomes 20 meter per second. So you can start from any way to draw the point X. Then move to the left for starting first section, move to the left. Then after that, yellow region here, move to the right, change direction. So your displacement, it should be equals to 1 over 2, 12 minus 4 times the height is 20 minus 1 over 2, 4 times the height is 10. So your answer should be 60 meter. Okay, Chloe, do you have any other question? You get okay. Clement, did you get the idea? Why how we get this 60 meter? Okay, The rest of you is it okay? This is last question for this question. Okay. If okay, then we are going to proceed to page 14. Page 14. Is it okay? 14, move, Okay, here, move. Okay, a child at theater. Total mass going up, travel in a straight line up. Okay, so up, keyword up. When up, what is the motion? So we relate it with this. You see what happened to the motion? Velocity decrease, right? Velocity decrease. Then after that, pass through point A at the speed 80 meter per second at time equals to 0. So here t equals to 0. And then come to rest. You see, comes to rest must be that the speed decrease. Okay, at the end comes to rest. So meaning that in the whole process at here, whole path at here, velocity is decreased. So until here, the velocity is become 0. So this one is starting. Okay, then next. The child apply a brake to the point B, or at point B apply a brake. The brake doesn't keep it stationary, and then it will going back here. So it will move backwards. Move backwards, just now is moving forward, going up. Now it's going down. So that means your velocity should be a negative because opposite direction. Opposite direction. So can you see that at here, this is the part showing opposite directions. So which means that this one at point B, time is actually 12 seconds. Do you agree? Okay, look at it and then digest what I say. It going up, come to rest. That means that speed decrease. Even they didn't tell us, we also can know that speed decrease is because going up against the gravity. So velocity decrease until point B comes to rest. Velocity is 0. So that means that at here, velocity is 0. That means this is at point B. This is at point B. Here is at point A. Okay, then after that at point B, the brake doesn't able to hold, so it will going back. Okay, it will going backwards. So backwards, that means opposite direction. Your graph should be goes to the negative region. So that is the part. After 12 seconds to 24 seconds, that is the part. Okay, until here, do you able to get the idea matching the graph and the diagram and the situation? Is it okay? Yes or no? Clement okay. How about others? Jiaxuan okay. Chloe okay. Sergeant, do you able to follow? Ryan? Wei Tong? Okay, Okay, dear, we look at this. State the time taken for it to travel from A to B. From A to B, how long the time? Actually, I already interpret for you. So at here, from point to B point, we took 12 seconds. 12 seconds. A point to B point. How I know B point at here is because velocity becomes 0. So I know that B point actually is at 12 seconds. Okay, next question. Can you determine the displacement from point A at time t equals to 24? Okay, can you try? Want to calculate the displacement up the slope from point A at time t equals to 24 seconds. So we start from point A. After 24 seconds, what is the displacement? Jiaxuan, yes, correct. Very good. How about others? Jiaxuan already get the answer. Chloe, correct. Any others? How to find displacement? Clement, correct. Okay, so at here, this is the triangle. And then here, this is another opposite triangle, opposite direction. So you want to find your displacement using the bigger distance, which is 1 over 2. The base is 12. The height is 18. Here is 18. So this one you should able to get 108 meter. Okay, if you're able to get this answer, you got score 1 mark already. Here got 3 marks, total 3 marks. Please show working step. Okay, another one is, this one is distance for section A, section B. The bottom part, 1/2, the base is 24 minus 12. 24 minus 12 times the height is, this one how many? This one should be 6. Yes, 6. So your answer should be 36 meter. If like this, you're able to show 36, or you able to show this working step, you score another 1 mark because you able to find the distance for that time period. Okay, period of time. So next, okay, so this one we can interpret in moving to the right, okay, going to the up lah, okay, it's 100, or we say it here. From A point to B point, from A point to B point, A to B is 108 meter. Then from B, it going back to somewhere here is 36 meter. Okay, where is your, what is your displacement? Displacement should be here to here. Okay, here to here. So how should we do? We should using 108 minus 36. So your answer should be 72 meter for displacement. Is that clear? 72. So 3 marks. Here, 108, or you showing the triangle area under the graph for this triangle, yellow color region, section A. So this one, 1 mark. Then section B, 2 mark. Final, you know that minus, so you get the third mark, the last point. Is that clear? Yes or no? Yes, good job. So answer is 72 meter here. Okay, we proceed to the next question. Show that accelerations as it moves from B backwards towards A is 0.5. Move backwards, showing the acceleration. Okay, showing the acceleration. When move from B to A, so which region? Blue color region. What is the acceleration? Velocity time graph acceleration. What should we do? We calculate the gradient. Okay, gradient for the VT graph. Okay, it will showing you acceleration. So how you find acceleration? Find gradient. Okay, here 6. Should I put negative 6? What do you think? Should I put negative 6 divided by, I draw this triangle. The time should be 24 minus 12. Okay, so which is your y2 minus y1 divided by x2 minus x1. Okay, deal. Should I put a negative? What do you think? Should I put a negative? Then at the end, I get negative 0.5 meter per second per second. Should I put a negative for this? For the velocity part, the y-axis, should I put a negative? My answer is no. If you put a negative, then your answer for acceleration, you get a negative. That means that you decelerate. Ask yourself, is it decelerate? Is it decelerate for this part? In moving downwards here. Is it decelerate? From 0 to negative 6 meter per second. It's actually accelerate. The negative is just showing direction. It doesn't mean the value. So at here, when we do this, we don't need to put a negative. If you put negative at the end, you get a deceleration. This one, from here to here, actually is the velocity is u equals to 0. Final is actually negative 6 meter per second. But the negative is just showing direction. The actual value for the speed is 6. 6. Get it? So this is the last part. It proves that acceleration is 0.5. Finding the gradient, but no need to put negative because the velocity negative is just direction. Okay, it's just direction. So you look at 12 seconds. the velocity is 0. The 24-second velocity is 6. Is that clear? Velocity is 6. So actually it is speed up. Okay. Chloe, okay. How about others? Get the idea? Clement, okay. Sergeant, okay. So we move, Let's go. Okay, this one. A small block is lifted vertically upwards. So it's going up, going up. So circle up. So up, what is your motion? Okay, here. The block is moving up. The string break at time t equals to 0. Oh, the string break. The block initially continue moving upwards. Okay, the block initially continue moving upwards and then fall and hit the ground at time 0.9. This is the velocity time graph. So the block initially is still going up for a short moment, then only at maximum height is going down. Okay, then here. Air resistance is negligible. State the features of the graph that show that the block have constant acceleration. How you know the block have constant acceleration? What features of the graph showing that the block has constant acceleration? So what is your answer? How you relate this graph and show you, hey, the motion is constant acceleration. Chloe, correct. Jiaxuan, yes, but Jiaxuan, your answer not complete. Constant gradient, showing constant acceleration. Write one more word, constant. Constant gradient. So I know that it is constant acceleration. Okay, so from the graph, I know the motion is constant acceleration. How you know? Constant gradient. Okay, so next, at here. Use the figure 2.2. Determine the height of the block above the ground when the string break at time t equals to 0. Okay, initially, the object still moving upward for a short moment until here, right? And then it will fall, okay, until it hit on the ground, right? Okay, here the question asking you determine the height of the block above the ground when the string break. When the spring break. So what they want? They want this part. Initially, when its string is break until what is the height at here? So they want to find this. They want to find this distance. So what is this distance they want? Do you know? Okay, so let me capture it here. This one. Those you got idea, you can try already. Okay, here. How you find this S? Chloe, correct. Chloe, correct. So there, starting, it will move upward. So this is the distance travel. Then it will going downwards. So this is the distance travel downwards. So they want to find starting until the end. Okay, the string break, this is the starting position. Then until above the ground, this is final position. So at here, the distance for this part that we want to find, actually they're asking you what is the displacement. What is the displacement? They want you to try to interpret the sentence. Actually, they want you to find displacement. Sergeant, yes. Sergeant, in AS, our final answer will be given to 2 to 3 significant figure. So you can make your answer as 2.2 meter or 2.21 meter. Okay? So boys and girls, here, let me highlight. Okay, this is the distance for this part. Okay, then after that, pink color, is the distance for this part and then here. So what is your displacement? Your displacement should be the height. It's actually the section 2. Okay, section 2 is actually 1 over 2, 6.x6 times the 0.9 minus 0.9 minus 0.2 minus 1 over 2, the small triangle, 0.2 times the height, 1.96. Okay, if you do everything correct, you should be able to get 2.2 meter or 2.21 meter. Okay, so at here, this part, let me think what I want to say just now. I suddenly hang. Da, 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 da. Okay, this is 1 mark, here 1 mark, here 1 more mark, 3 marks. This is how they give you the marks. Is that clear? You need to have the situation, interpret the situation. String break, this is initial position. Okay, the height from above the ground, this is final position. Initial until final, that is the displacement. So your answer should be 2.2. Okay, here D, on figure 2.3, sketch a line to show variations of the distance moved by the block with time t from t equals to 0 to t equals to 0.2. Oh, okay, they're asking about the blue color region. Variations of the distance moved by the block. Numerical values of the distance are not required. Okay. Okay. So this is distance time graph, dear. Distance time graph. Ask yourself, what is this motion? So at here, velocity decrease. Do you agree? Velocity decrease. 1.96 to become 0. Velocity decrease. So how you are going to plot the graph, distance time graph, when velocity decrease? Okay, my answer is it should be like this. If I draw the gradient, can you see that the gradient decrease? Less steep, meaning that velocity decrease. Answer should be this. You should curve in this way. They want you to interpret the motions and then sketch in distance time graph. Okay, so this one is only the blue color region. They are asking you blue color region. 0.2. This is this region. T equals to 0 to t equals to 0.2. Okay, velocity decrease. Any question? Any question? Is it okay? No response? Chloe, okay? How about others? Is it okay for you? Clement, okay? Sergeant, okay? Okay, last question, my dear, before we end our lesson. Velocity time graph for the two car, P and Q. Okay, the car travel in the same directions, okay, because both are positive region, positive velocity, so it's in the same direction. It makes sense, okay? Then after that, car P pass car Q at time t equals to 0. Okay, car P pass car Q, okay. Then the speed limit for the car on the road is 100 km per hour. Set and explain whether car Q exceed car Q away, car Q. Okay. Okay, for the car Q at here, the highest speed for car Q is 30 meter per second. Am I right? This is the fastest speed. So we want to know that this speed, whether it is exceed the limit or not. Okay, how should we do? We can do conversions to the kilometer per hour, or we make the kilometer per hour convert to meter per second. So to do conversion, it depends on you. Okay, so maybe I can change from 100 kilometer per hour. I write in this way, per hour. So I want to know how many meter per second so that I can compare and I know that whether the car Q need to get summon or not. Okay, so this one should be 100 times 10 power of 3. 1 hour is 60 minutes times 60 seconds. So your answer for this, if you press it blah 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 blah, it should be get 28 meter per second. So our limit is this. The car Q is 30 meter per second. So is it the limit? Yes. Okay. So at here car Q exceeds the speed limit. Okay, is it the speed limit? Stat and explain. Our calculation is the explanation. Because it's greater, okay, 30 meter per second greater than the speed limit, 28 meter per second. That is. So at here, unit different, hard to compare. Please convert it. So you might be convert from kilometer per hour to meter per second, or you want to convert meter per second, convert to kilometer per hour also can. After they having the same unit, then you only can make comparison. Okay? Calculate the acceleration. This is velocity time graph. How we find the acceleration? Just now I did mention what? Find the gradient. So what they want? Car P. Car P find the gradient. Okay, gradient for car P at here, it should be, this is 20 what? 1, 2, 3, 4. 24 minus 20 divided by the time. So I'm using this triangle idea. This triangle. I can't draw very exactly on the line. Okay, like this. 12 seconds. So for car P, the acceleration should be 0.33 meter per second. Using gradient to find the acceleration, that's all. This one should be quite straightforward lah, okay? So this is question B. Question C, question C. Determine the distance between two cars when the time is 12. Well, how far the distance between these two cars? Okay, so what should you do? How far their distance? So you should find how far the total distance traveled by car Q and how far the distance traveled by car P. Area under the graph, you don't calculate this triangle only. It's the area under this line until your x-axis. This is the area traveled by car P. Okay? So at here, we calculate the distance for the car Q first. Car Q is triangle, so easy. 1 over 2, the height is 30, the base is 12. So at here, your answer should be 180 meter. For car Q, it travel 180 meter. Okay, how about the car P? Car P is a shape like this. I'm using my highlighter. The shape is like this. Okay, you can calculate using the trapezium. There you can calculate using trapezium, like this. Okay, trapezium is 1 over 2. Then 20 plus 24 times the height is here is 12. So your answer, if you do everything correct, 264 meter. Okay, this one mark, here 1 mark. How far the distance between these two cars? One car travel to 264, one car travel 180. So their distance just minus. So at here, distance equals to the 264 minus 180. Your answer should be 84 meter. So total 3 mark is here for question number C. Just now is question number B. Is that clear? Is that clear for this part? Chloe, okay? How about others? Is it okay? Clement, okay? Sajan, okay? Jiaxuan, okay? Okay. So last question is the main part. Why I put this question in our worksheet. Okay, we look at the last question. From the time t equals to 12, velocity of each car will remain constant. It will remain constant. So speed doesn't change after t equals to 12. Determine the time when what time the car P pass car Q. Okay, car P need to pass car Q. This one, you have to make sure before it pass, at the moment it pass, actually the distance traveled by car Q must be equal to the distance traveled by car P. Must be. Okay, before time equals to 12 seconds, how far the car Q travel? The car Q travel 180 meter already. Then before 0 to 12 seconds, car P travel 264, right? At this t equals to 12 seconds, still copy at a larger distance, okay? Further away from the car Q. So we want to know when the car Q pass car P. So when it pass, its distance must be the same. Then at the next moment, it will be pass, okay? So at here, they say that velocity remain constant. Velocity is the distance divided by time. Am I right? So the distance will be the speed times time. Okay, car Q at 12 seconds. Car Q at 12 seconds, the speed is 30 meter. At 30 meter per second. So the 30 meter per second times the t. This will be the distance traveled after 12 seconds. But how long the time we need to find it out lah, okay? So for the car P, it already traveled 264 meters when 0 to 12 seconds. After 12 seconds, the speed after 12 seconds, it should be 24. Is it 24? Here is 24, 24. So it will maintain at 24. It will maintain at 24. Okay, maybe I can draw like this. 24 times the time. The time unknown. How long the time? Okay, this one just now the graph is something like this. And then the another graph is something like this, right? Okay, let me draw like this. Okay. Then here, this is at time 12 seconds. Okay, how long the time they travel? Actually, we don't know. But we know that after that, it travel in a maintain at the constant speed. Okay, so this one is 30. So this one at here is actually 24. So it will be also maintained. Okay, until a certain moment T2. Okay, this one is T2. Here is T2. Until a certain moment T2, their distance travel by the car P and car Q will be the same. This T and this T must be the same, must be the same. At a certain time T2, this area under the graph will be equal to this area under the graph. Okay? Because maintain the velocity, so your graph should be a horizontal. When we find the distance, it should be the horizontal, the height times the time. So this one, the speed times the time. This question, the main idea that I want you to know is car P pass car P, Q pass P. You must fulfill that distance at the time is the same. Okay, at this time, the distance must be the same. So if I continue plot the graph, constant velocity, it should be horizontal continue until a certain time. Okay, then these two area, because this the front area, this one I did calculate already. What just now we did calculate 180. Okay, then plus this part 30 times the time. The time at here we don't know. This is our time. We don't know t. Okay, this is t, not t2, t. The time in between. So this is t. So here, from here to here is t. Okay, then after that, this one P, okay, the red color is P. So let me label this is P. So blue color is Q. Okay, for the P, the front part at here we did calculate 264 already. Then behind here is 24 times the t. So if you do everything correct, then your time at here you will get how many? Is it 14 seconds? Okay, determine the time. Can I say that my time is 14 seconds? My answer is no. Determine the time. At what time the car Q can pass car P? The 14 is only for this part, 14 seconds. 14 seconds for both of the car maintain at velocity, constant velocity. So what is your actual time? It should be 14 T2, it should be 14 plus 12. So your final answer for this question, it should be 26. It should be 26 seconds. Okay, let me check Chloe. Okay, Chloe, did you get the idea for this? Yeah. Okay, boys and girls, the rest of you, did you able to get this idea?
Teacher,
Yes,
I
dear.
I used another way, but I got the wrong answer.
You got the wrong answer. That means that something idea in between is wrong. What is your idea?
I use S equals to UT plus 0.5 AT squared. So first I calculated the acceleration.
You calculate acceleration for
Yeah.
what? Why you calculate acceleration for what?
Oh, is it because if
No?
if behind is like straight line, then cannot calculate acceleration already.
Yeah,
Oh,
acceleration will be zero already.
yeah.
Then here, car Q pass car P, the main idea is distance must be the same. That is the thing. Okay?
Oh.
So the rest of you, any question? If no question, then that's all for our lesson today.